Kinematics is the science of describing the motion of objects using words, diagrams, numbers, graphs, and equations. In fact, kinematics is a branch of mechanics. So the goal of this kinematics is to develop sophisticated models that serve to describe the motion of real-world objects. In this lesson, we will investigate the words used to describe motion of objects, and we will focus on the language of kinematics. As a matter of fact, in our last lecture, we discussed about scalars and vectors. So to give you a review, scalars are quantities that are fully described by a magnitude only, without any direction. However, vectors are quantities that are fully described by both the magnitude and direction. So to give you an example, let's talk about distance and displacements. These are two quantities that may seem to mean the same thing, yet they have different definitions and meanings. So when we talk about distance, this is a scalar quantity that refers to how much ground an object has covered during its motion. On the other hand, when we talk about displacement, this is a vector quantity that refers to how far out of place an object is. It is the object's overall change in position, because since that's a vector quantity, it already involves direction. So to have a clearer picture about the distinction between distance and displacement, consider the motion depicted in the diagram. A physics teacher walks 4 meters east, then 2 meters south, then 4 meters west, and finally 2 meters north. So in this case, even though the teacher has walked a total distance of 12 meters, her displacement is 0 meters. During the course of her motion, she covered 12 meters of ground with a distance equals to 12 meters. Yet, when she is finished walking, she is not out of place. There is no displacement for her motion. So the displacement is equal to 0. So that would mean that being a vector quantity, this displacement always give attention to the direction. The 4 meter east cancels the 4 meter west in the motion of the teacher, and the 2 meters south cancels the 2 meters north. But when we ask about the distance traveled, which is a total distance, having a total distance of 12 meters, it doesn't consider the direction. It determined only the overall distance traveled by the teacher, regardless of various direction of motion, um, in which this direction is really ignored. Now let's proceed to the distinction between speed and velocity. Speed is a scalar quantity that refers to how fast an object is moving. Speed, speed can be thought of as the rate at which an object covers distance. A fast-moving object has a high speed and covers a relatively large distance in a short period of time. In contrast, a slow-moving object has a low speed. It covers a relatively small amount of distance in the same amount of time. And an object with no movement at all has a zero speed. Meanwhile, a velocity is a vector quantity that refers to the rate at which an object changes its position. Imagine a person moving rapidly one step forward and one step backward, always returning to the original starting position. So this activity would always result to zero velocity because the person always returns to the original position. The motion would never result in a change in position since the velocity is defined as the rate at which the position changes. So this motion results to zero velocity. So if the person would like to maximize their velocity, then the person must make an effort, okay, to maximize the amount that they are displaced from the original position. So every step must go into moving that person further from where he or she has started. But if the person never change direction and always go back to the starting point, then the velocity is zero. Because velocity is a vector quantity in which direction is always very important. So when you are describing a velocity of an object, then you have to consider the direction, like 5 kilometers per hour east. So that will ensure that that description is a velocity. Because if there is no direction, then we call that one as speed. Okay, so how to compute average speed and average velocity? So the average speed during the course of a motion is computed as using the following formula. Average speed is equal to distance traveled divided by the time of travel. So let's have an example. While on vacation, a man traveled a total distance of 440 kilometers. His trip took 8 hours. So what was his average speed? So using the formula, speed is equal to distance over time. So 440 kilometers divided by 8 hours. So this is equal to 55 kilometers per hour. Now let's consider the motion of the previous example. So the teacher walks 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. So the entire motion example lasted for 24 seconds. So let's determine the speed and the velocity. So the teacher walked with a distance of 12 meters in 24 seconds. Thus, her average speed is 0.50 meters per second. You just divide the distance, which is 12 meters, and the time is 24 seconds. So the result is 0.50 meters per second. However, when we compute the displacement, because the teacher have a zero displacement, go it go back to the original position, so the displacement is zero. So the teacher's average velocity is 0 meters per second because velocity is displacement over time. So the displacement is zero. It is because the teacher goes back to its original position. So there is zero displacement. So since there is no position change, um, 0 divided by the time, which is 24 seconds, is of course 0. So the velocity is 0 meters per second. Now let's go to acceleration. So acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. So an object is accelerating if it is changing its velocity. Acceleration has nothing to do with going fast. In fact, a person can be moving very fast and still not be accelerating. Acceleration has to do with changing how fast an object is moving. If an object is not changing its velocity, then the object is not accelerating. So anytime if an object's velocity is changing, then the object is said to be accelerating. It has an acceleration. So when we calculate the average acceleration, so the average acceleration of any object over a given time interval can be calculated using the equation. Average acceleration is equal to velocity over time. So the velocity can be dissected into v final, velocity final, minus velocity initial over time. So using this equation, for example, an object starts from rest. Okay, so if that starts from rest, so the initial velocity is 0 meters per second, and a final velocity of 50 meters per second, and traveled final velocity of 50 meters per second. Let's consider that there is a direction on it, whether north, south, east, west. Let's just assume that there is a direction, because you know velocity is a vector quantity over a period of 5 seconds. So utilizing the formula Vf, V final minus V initial, so the final velocity is 50 meters per second minus the initial velocity is, since the object starts from rest, okay, then moving up to 50 meters per second. So the initial velocity from rest is 0 meters per second divided by the time, which is 5 seconds. So the result is 10 meters per second squared. So since, as what I have mentioned, acceleration is a vector quantity, it should have a direction associated with it. It can be in a form of uh, a concrete direction. However, the direction of acceleration is actually dependent on two things: whether the object is speeding up or slowing down, acceleration and deceleration, or whether the object is moving uh, in the positive or a negative direction. So we can consider that one in acceleration. So that is why you cannot anymore see the the direction like north, south, east, west, because the acceleration as a vector quantity will always depend on the speeding or the slowing down, or positive direction or in negative direction. So, for example, if an object is slowing down, then its acceleration is in the opposite direction of its motion. Okay, I hope you have understand well our discussion about kinematics, the different description about motion, the formula in the computation of the different quantities, and of course the application of that formula to solve certain problems related to motion.